Finish the acid-base stuff. So where we left off, I'm going to play from the current slide. We left off on this slide. Remember we have the whole concept of conjugates, all right? And the conjugate of a weak acid is a weak base. The conjugate of a weak base is a weak acid. Conjugates differ by a proton. All right, so let's talk about pH for a moment. So pH is a measure of acidity, and technically it's a mathematical operator. So it's P means the negative log of, so the negative log of H, right? And that's what pH is. So it has to do with the H plus. So remember H plus H3O plus. So it's a measure of acidity basicity. Now we hear about it a lot in popular culture. pH balanced shampoo, an alkaline water or something like that. So alkaline, by the way, is a synonym for basic. So basic and alkaline are synonyms. So the alkaline water means that it's basic. So all that stuff is just advertising, or they're playing on, it's the same thing that people play on the fact that the general population has a small amount of knowledge about things, right? your body does not have a single pH, so your stomach is very acidic, your small intestine is a little bit basic, your blood is basically is neutral. Even inside of a single cell there can be acidic and basic environments, so you don't have a pH. All right, but it comes up a lot, so we'll talk about this. This is what it is. We're not going to do the math in this class. We haven't yet, and there's no reason to start now. All right, so if you increase the amount of H+, a more acidic solution, by the way, this means concentration of like parts per million, right? More H+, that means this number goes up, which means pH goes down because of the negative. Okay, so acids have low pHs. If you increase the hydroxide reacts with acid, right? H plus OH minus will form water. So if you increase the hydroxide, you're going to decrease the H plus. If this goes down, pH goes up. So we have bases have higher pHs. Okay, 7 is neutral, and that's because these would be in equal amounts, right? So 7 is neutral. If it's less than 7, it's acidic. Lower, more acidic. If it's greater than 7, it's basic, or alkaline, higher, more basic. So pH 8 is basic, pH 9 is more basic. All right, let's talk about acid-base reactions for a moment. So when acids and bases react, they typically form water and another compound. The other compound is referred to as a salt. A salt is an ionic compound. So if this was, say, HCl and NaOH, you would have NaCl. Right, NaCl, so and the H and the OH make water. Right, that's what they do. So try these on your own, see if you can come up with the products. Hit pause, and I'll come back and we'll do this, see if you can do it on your own. Okay, hit pause, try it on your own. Are you back? Did you try it? Well, let's see how you did. So remember, you're going to have the H with the OH to make water, and then the Na with the Cl. The H with the OH to make water, the K with the sulfate, right? So let's see how it comes out. I even balanced them for you. So H, if you want to write water as HOH, if it helps you, then write it that way. A lot of people write water that way, right? And so NaCl, KSO4, but remember, we did this before with nomenclature. The SO4 is the -2, so that's why it's balanced. All right. The last aspect of acid-base chemistry that we're going to go through in this class is buffers. So buffers are solutions that resist, they don't prevent, they resist. So they slow down changes in pH. So if you add acid to, well, I'll show you the next slide, all right? Now if you think about, so acids are H+, right? An acid solution is a bunch of H+ ions and some other stuff. A basic solution has hydroxide ions. Why would we want a solution's pH not to change? Well, if you think about it, let's use our bodies as an example. Let's look at our blood. So your blood pH is right around neutrality. It's very close to neutral, very close to 7. Yet your blood gets all sorts of stuff dumped in it. Everything that goes in your body gets into your blood. So if you drink a soda, which is acidic, or orange juice, the acid's going to go into your blood, right? But your blood pH doesn't change because it's buffered. Now, why would it be bad if it did change? Well, specifically, your body has a lot of molecules called proteins, and proteins are really important. They do a lot of the work, and we'll talk about that when we do some biochem later. But proteins are involved in a lot of chemical reactions in your body. So a good example is hemoglobin, which is a protein in your blood that carries oxygen. Proteins can be very pH sensitive, so hemoglobin works at a certain range. If your blood was to get too acidic, hemoglobin wouldn't function. If your blood got too basic, hemoglobin wouldn't function. And if hemoglobin doesn't function, you can't transport oxygen, and you would die. So that's why it's important that things are buffered. And even in a lab, sometimes we don't want things to get too acidic or basic, especially if you're working in biochemical systems or biological systems. That's an example. All right, so let's look at what they do, and then we'll look at how they do it. All right, so this is what I mean by a buffer resists changes in pH. So if I was to measure pH of water and add acid to water, so I'm just adding more acid to water, the pH will drop, and it'll drop very quickly. If I take a buffer and I add the same acid to the buffer, you see how the pH drops much more slowly. Okay? By the way, they're not necessarily at 7. The buffers can be at pH 4, pH 9, whatever pH you want. You can make a buffer to keep the pH anywhere you want. But it'll change, but see how it changes much more slowly? The same buffer can neutralize base. So this is a similar graph. If I add base to water, the pH will go up, and it will go up very quickly. But if I add base, hydroxide ion, to a buffer, it goes up, but much more slowly. Okay, so that's what they do. They resist changes in pH. Now, how do they do that? Well, how can you neutralize acid? You have to have a base. How can you neutralize base? Well, you have to have an acid. How can you have an acid and a base in the same solution, and yet they don't neutralize each other? Well, that's where conjugates come into play. So HA and A minus, for example, are a conjugate pair. If I transfer an H plus from here to here, here's an acid, here's a base, I get the same thing. Try it on your own. Right? So if I have a mixture of a weak acid, weak base conjugate pair, I have a buffer. So that's what a buffer is. It's typically a mixture of a weak acid, weak base conjugate pair. And it has an acid that can neutralize base, and it has a base that can neutralize acid. So to show you how it works, it's very important to realize it's a mixture. The buffer does not react with itself. Right? So if I was to say, show me how a buffer can neutralize acid, or show me how a buffer can neutralize base, we'll do generic and then we'll do a real one. So buffer neutralizing acid, so we just do the buffer plus H plus, but it's not the whole buffer, it's only the part that reacts. Which part of the buffer will react with acid? The base. All right? Remember, the base is always one proton less than the acid. So if I take the base plus H plus, right, you see how I get an acid, but it's a weak acid, so the pH does go down, but not as much because it forms a weak acid. So I take a strong acid, turn it into a weak acid. Similarly, the acid component of the buffer can neutralize base. So we show the acid reacting the acid component of the buffer. So the A minus and the HA are the buffer. The buffer reacting with acid, buffer reacting with base. And you can see the strong base gets converted into the conjugate of the weak acid, which is a weak base. Does the pH go up? Yes, it does, but not very much. Okay. So you try this one on your own. This is the last slide. The answers will be the last slide. Hit pause, try it by yourself. Show this buffer, the acid component reacting with base, OH, the base component reacting with acid, H+. Right? 2 separate reactions. Hit pause and give it a go. All right, did you give it a try? See how you did. So this is how you do it, right? You say, okay, which one's the acid? That's the first thing you have to know. Here's 2 of them. Whatever one has more H's is the acid. So ammonium is the acid. So you show the acid reacting with base, hydroxide ion. And all you do, as I showed you, acid-base chemistry is always protons going from an acid to a base. So you take an H plus off of here, put it on here, HOH or H2O. If I subtract this, I get this. All right, and here I have the weak base component of the buffer reacting with acid, so the H plus is going this way. There you go. All right, so that's all we're going to do with acid-base chemistry. You should be able to do the homework material, the homework over this material, which is posted now. I believe it's homework, I have to look at the number, 10 or 11, but it's on the Canvas site. All right, I'm available on Zoom if you have questions.